Hello everyone, it's Peter from the DevRel team at R3. Welcome to today's session on Corda accounts workshop. Today is the second workshop of the August workshop series. The first one is the Corda developer bootcamp. Today's workshop is on Corda accounts. The third one will be on how to write testing for your Corda. So let's go into some reference of the Corda community. So we have our YouTube channel here at youtube.com/CordaBlockchain. You can join our Slack community by go to the slack.corda.net. Our documentations is docs.corda.net. We have a free training site at training.corda.net. And our GitHub repository is github.com/Corda. If you have any questions, feel free to email us at devrel@r3.com. My coworker David Awad will also help you answer any question that you have during the session in the chat. And lastly, feel free to tweet us at Twitter at Corda Blockchain and inside R3. So next, before we go into the accounts workshop, let's do a quick recap on what is a CorDapp to fresh up everybody's memory on it. We went through a full development of a CorDapp in our last sessions, and we're just gonna do a quick recap. So a CorDapp consists of three foundational components: the Corda states, Corda contract, and the Corda flows. The Corda states are objects in Corda that get consumed, updated, and stored. Oh, actually, let me change view here. That's better. So second, the contract. The contract verifies the transaction. So if you see the screenshot right here on the screen, these are actual codes inside the Corda contract files. So if you want to pass a transaction between different counterparties, you need to get through all the contract rules. If one fails, the transaction will get rejected. Lastly, the Corda flows. The flow executes the business logic. All the calculations, verifications, signings, and data writing will get all executed in the flow. So that's basically a quick one minute recap on what is CorDapp. So let's go to the real content of today's workshop, Corda accounts. So why did we build the account features? Because we see the opportunities because we see some opportunities. We believe that DLT technology can be deployed and operated by individuals and small business. That can be anyone actually, such as your local corner store or a friend named Roger. We also see the opportunity for existing customers to reduce their total cost by spinning up distributed identity on behalf of their clients. So if you think about how blockchain works, each so-called distributed or digital identity, they all required like an independent node that hosts their service on. But with Corda accounts, you can have one node, but multiple identities, or how I can say like entities or companies that's get hosted on a single node. So that will significantly reduce the cost of starting up or of participating into a blockchain system. And lastly, all of this will help us boost the scalability of the applications. It's a huge opportunity for massive adoption of decentralized applications. So what did we create? We create a package called account library. So the account libraries allows the Corda node operator to split the vault into multiple logical subvaults. So what are we looking at here? If you attended our previous session, you can see that we show the picture of a simple Corda network. We have a network identity manager and some nodes. Then what's the next step? With a Corda library, we can create some accounts that are hosted by these existing nodes. So each real life identities can be represented by multiple nodes in terms of accounts. It's like you have multiple bank accounts under the different banks. You as a person, you are the unique one. You are yourself. However, you can have multiple accounts under different nodes, or if you're thinking from the nodes perspective, like from the node operator perspective, you can have one server or like one service that covers multiple accounts. So what we have achieved here, we bypassed a common limitation of many DLT systems is each node can only represent one identity. In the picture explanation of the accounts library, we can dig a little bit deeper to see it in action from the snapshot of a database that shows like here. So if you have work with Corda applications, you have worked with Corda before, the database that live inside of the Corda node is called a vault. And we have for developers. From developers' point of view, we have like a method called vault service. So all of the database queries, if you're operating on the Corda system, will go through the vault database. And in this mock node database, we see that node has some blocks of data that are squared with account 1 and account 2, and there are some ones out there without any account labels. They are labeled with no account. That's exactly what's going on in the database. So when you utilize accounts library in your CorDapp, the designated data block will be tagged with accounts IDs. So what are accounts exactly? So they are just hashes and unique identification IDs, like the UUID, that you can tag on your data block. We will go into the source code later to actually show you what is the account info. But behind the scene, you see your data is tagged with accounts, and the identity service will successfully identify which hash, which key belongs to which account, and the key are stored in the key management service as the rest of the key are stored at. So that's basically the technical breakdown of the Corda accounts system. Any question? Cool. So basically, in a summary, utilizing accounts in your CorDapp is just equal, you tag your data block with a specific accounts ID, and whenever you want to query the accounts, queries the data, you use that specific account ID. So that will help you better filter and query data. So that's basically what accounts achieve in a different way to explain it. Cool. However, I do want to point out some not so obvious things here. It's it's quite important. Some people may ignore it, but I want to make it clear for the people out there that there are two things. The first one is accounts are not Corda identities. So they are just a different representation of a collection of states and public keys. accounts in the node does not does not equipped with X500 names. That's what the Corda network recognize. So accounts are not recognizable from the network level. If you want to do business with other people's accounts, they have to actively share with you. Then you store their keys in your database, and then you can start doing business with them, like doing transaction with them. So that leads to another it's not a caveat, but another aspect is Corda accounts will not get automatically discovered by other nodes. So that's actually it's actually a good thing, because the counterparty will not know the existence of some of your accounts unless you actively share with them. That actually adds another layer of security, sense of security, just right there. But the whole again, the point that I want to emphasize here is Corda accounts are not Corda identity. There's still a difference there. And the second is physical vault isolation is not supported. So all the accounts information and the keys are stored in the same key management service, the same identity service management inside the hosting node. So that means the node operator has the total accessibility of your accounts data, because think about it like a real bank. The bank, the customer service representative, after they go through some security check with you, ask for your social security number and your password, or your home address or your passcode, they can actually see your data because the database is technically open to them. Whether you like it or not, they can look into your bank account. I mean, in real life, they will ask you for all the consensus, but technically, I'm talking about this on a technical level. It's like they have the database, they have the control of the database, and same thing will goes on here. Is the node operator will have full visibility of the accounts data because technically they own the account. And if you're thinking about alternatives or a solution out of this, standalone hardware secure HSM private key and public key management is currently in research, and it's not supported yet, but we have ongoing research at R3. So we are looking into how to resolve this. So if you think about it, as ultimately the most ideal way to work with Corda accounts is the node has a key management service or identity service that manage the node's identities, and then all the accounts, if they don't like the node managing their identities, they can start their own key management service outside the node. So that's the most ideal way, but currently it's not supported, and we are doing research on it right now. Cool. Any questions? So if you have questions, just comment in the chat. My colleague David Watt will help you answer. Cool. The next one. So with a little bit more understanding of what's going on inside the Corda node with Corda accounts, with how the key management and the identity set up, what we can actually do with Corda libraries. So with Corda accounts, a simple 3-node network basically can operate with much more flexibilities. Because originally, if you have a 3-node network, you can only do transaction between A, B, between A, C, between B, C, or a transaction involve all A, B, C. But now, you can basically do accounts to node transaction, and vice versa, and accounts to accounts transaction across 2 nodes. It's from A1 to C2, right? As I showed here, and also you can do account-to-account transaction within the node. So at the end of this workshop, I will actually show you the links that have some demos that show exactly how you do each of the transaction. With all that flexibility, what are some use cases that we can build? So the first one that on top of our mind, or like, you know, we also talk to the communities, some of our developers out there, that they have ideas around custodianship like accounts, such as bank accounts or like brokerage accounts. And secondly, application that involves multiple teams in a large company, so they can do transactions or like they can separate or isolate sensitive informations from non-evolving departments. You can actually refer this to the supply chain example that we built, and you will find that in the link at the end of this workshop. So basically, that's the second type of applications, and then the last type that some of our developers or community developers think of is the massive to consumers applications. So each node can represent millions of customers, like a music app, music, the copy, like the real piece of work is copyrighted and only shared with a need to know basis between the artist and the playing platform. And the platform basically is a Corda node, and then inside the node, people can sign up with their credentials, and then they become Corda accounts. And the Corda accounts then can be participated into any transaction involve valuable digital asset. So again, what's the key that we see from here is Corda Accounts Library provides scalability to your app. All of the benefits, all of the features that Corda Accounts provided is about scalability. Cool. Next, we gonna actually going to look under the hood of Corda Accounts Library. We're gonna go into the code and see accounts info and account service, and then we're gonna go through the flow logic of like a typical accounts CorDapp, like what you're gonna do there. And before I go there, is there any questions that you have? Let me see. Cool. I think we don't have any question at the moment. I'm also checking our public Slack. Yeah, you can also find us talking with the community at slack.corda.net. That's where we primarily help the community to answer the question. Cool. All right. I will quickly jump to the IntelliJ and start our session there. Cool. Yeah. So what you see here is called account info. So what is account info? Account info is a Corda state that stores account information, and very clearly, from the comments or from the comments above the class, you can see that we have three properties: a name, a string, which is a name for the accounts, and then a host, which is a parent hosting node for the account, which is a party. So in the Corda system, a party is where you can identify it as with the X500 name, and that's also what's gonna get recognized in the Corda network. And lastly, it's a unique identifier because we want each account to be unique at the network level. And besides that, it's just it's a linear state, it's a queryable state. That means it's queryable from a database. And linear state is just like because it has an identifier, unique UUID as a identifier. So we know that it's unique across the network. Yeah, but that's about it. So basically, this is your account in the Corda system. Just a simple Corda state. And next, I want to show you guys like what's a account service. So account service is an interface that consists all the account relevant method. So if I scroll down a little bit, you can see that we have a method called our accounts that returns all the current existing accounts information that you know, whether it's the accounts on your node or it's the accounts that you get from the counterparty node. And this method is like the accounts for the host. So you can put your own host name there by like entering like our identity, right? Like it's another method called our identity. So that's actually gonna bring up all the accounts by you. If you enter your counterparty name as a parameter, it's gonna load up all the accounts for that counterparty. And all accounts basically is like all the accounts that stores by all the accounts stored in your node base. And we also see that there's like create accounts, account keys, account ID for keys, account info, so all that. So basically, remember, if you ever want to do accounts related method, you're gonna call the method start with account service. It's like account service or create account, stuff like that. Cool. So basically that's it. Like you have a Corda state that represents represents the actual object of the accounts in the Corda system, and you have an interface that allow you to do all the the good stuff with Corda accounts. So basically that's the foundations of Corda accounts library. Sure. Right now, let me actually switch back to the presentation because I want to show you guys a slide on the flow logic of a typical accounts CorDapp. So right now we see three parts of like the logic of accounts CorDapp. We have prior to the initiate the flow, and then we see the middle part is the inside of accounts relevant flow, and the last section is on data retrieval. So the reason we do that because with any typical CorDapp involving Corda accounts, those are the three parts that you need to basically make some modifications or changes to your existing CorDapp. Besides these three parts, all the rest should be the same for your existing CorDapps. Let me take some water here. So let's go to the first section prior to operating any accounts in the flow. It's fairly simple and very straightforward. Is we have to create and share our accounts to counterparty, right? We can call two methods. The first one is create accounts, and the second one is share with counterparty. So again, those two methods are pre-built by the package, so you can just call them. Second, is the interesting part is what we're gonna do during the flow. So we see here we have 5 steps here, and bear with me, it's gonna get a little bit complicated here. So first, Step 1, it says self-request a new key. So we will first self-request a signing key for ourselves, and also and then immediately follow with request a new key from the counterparty. So we are doing this because when we're utilizing the accounts feature in our CorDapp, you want to create a new set of public and private keys for each transaction. Why? Because when your counterparty decides to transact, the output states that are generated by the current transaction involving you and him, meaning that your account key and his account key are both as like the signing key of the transaction, to a third person. You want to have your own, you want have your public key properly masked, because the third person who has nothing to do with you still remain zero knowledge about you, even though he has one of your public key now. So this is why you want to create a new key pairs for every transaction. So like think about this. So you are doing a transaction, for example, me and my co-worker David. So we are doing a accounts to accounts transaction. And as I explained it before, accounts based at, if you look at the fundamental aspect of the accounts, is just a public key and private key pair. And David used his public key and I use my public key. We both use that key to sign the transaction, right? And in that transaction, we have one output out of the transaction. So that's basically, we can call it, that's a result of me doing business with David. And then now David has that result. And now thinking about David wants to do a transaction or do some business with a third person that person doesn't know me, and I don't know that person as well. But the transaction is about the result that David and my transaction. So the third person needs to have a way to verify the result of that output is valid. So the way how they can the third person can verify is we're gonna all send the third person our public key involved in the previous transaction. So the third person can see, oh, okay, so you got that transaction from you got that result from that transaction, and then that transaction has two public keys. Interesting. But at least, like, even though I don't know what exactly is that public key, but the transaction looks complete. The transaction looks legit, right? And then if he want to trace back one step forward, then we can like, he can request for other information, like going one by one doing the blockchain way, trace back to the origin. He can do that all he wants. But the key part of it is he will request one of my public key. However, if he has my public key, he knows that public key represents someone, right? Right now he doesn't know who's that someone. But just think about going into the future. If that person is ever gonna do some business with me in the future, and then for that future transaction, I use the same public key, the third person gonna be, okay, now I see. You use the same public key again, and I recognize that public key from the transaction that I did it with David, and then he gets some information that I don't want him to have. So that's a scenario that we don't want to get into. That's why the Corda accounts system require or like recommend or suggest you that every time you do a accounts transaction, you create a new public key and private key pair for that specific transaction. So your identity is properly masked for any unnecessary troubles going into the future. Okay, so that's a lot of explanation, but again, if you have any questions, drop in the chat, or you can email us. Cool. I will go to the next step. So the next step is actually set the account key as a state participant, because this is what indicates who stores the state. Step 4 is self-signing transaction with account keys. Depends on different use cases. Host node can also add their signature into the transaction as well. It's like, again, it's up to you. And lastly is collect the signature from the counterparty's account and finalize it. The third section is data retrieval. So since now that we endorse the concept of accounts, we have to be very, very careful on the queries now, because each account specific query has to strictly defined by the account query criteria. Again, this is a very this is very important, because all the state technically all stored together in the vault, right? If you don't do your query right in your applications, you're gonna see other accounts data when you do the query. When account 1 wants to do a query of his own data from the database, if your application is not properly written, accounts A can by accident query accounts B's data. That's just like, you have to be careful on that. And that's basically it. So that's how the 3 different parts of the logic of a typical accounts CorDapp. So I will go back to IntelliJ. I'm gonna show you first how to the code to create accounts, and then the code to share with the counterparty, and I will show you one demo flow that's begin with self requesting a public key private key pair, and then setting the participant, signing it, and then collect signatures, and then lastly I will show you the code to do properly do the queries. Yeah, so here we are back with back in the IntelliJ. So first, on the left we see that we are in the flows, we are in the workflows. We have a folder called account utilities, and here is our method to create account. And all of this is just it's a try catch, and what we are really calling the method is create accounts. So if I click on it again, you're gonna see that this is our interface. See here, our accounts, account info, right? And then here is create account. you may ask, like, why are you writing this like a wrapper method to have like an extra step of the code? So like, it's really up to you, because for example, for demo purpose, most of our samples will end with a string with a return string type, so we can properly show you that what you did for that specific method. But in production mode, or even like you are in the development mode, you constantly writing testing, testers, unit tests, integration tests. You cannot have a string as a return type, because all the unit testing there, what they need is return a signed transaction instead of a string object. So again, the implementation is entirely up to you, whether you want to write extra flow to put as a wrapper method to wrapper around the create account. That's up to you, or you can just like call them directly from a node shell or like from your flow. So again, this is a create a new account. Second is share account info too. Again, this is a wrapper method. So what we are wrapping here is just share account info. It's the account that you want to share, and then it's a list of the parties that you want to share to. For our wrapper method, we do a query first. We we queried the account by the name, and then we get the state and ref, and then we share the account information with the counterparty, and again return with a string return for the demo purpose. In our samples, I'm gonna share the link at the end of the workshop. In our samples, we also have a flow, different like a demo. In a different sample, we combine to create new account and share account into one method, because it's just you calling subflows, so you can create it right here and then just directly share it. But again, this is all for demo purpose, because you can basically compose or write your flow whatever you want. But yeah, that's it. That's basically you need to do for the first part, before you actually initiate the flow. Create the account and share the account. That's it. Second, let's go into the real meat here. So how you actually implement a flow that's involve Corda accounts. So this flow is called Start Game Flow. It's a simple tic-tac-toe game, and we code that game with Corda, so you can actually play tic-tac-toe on a Corda system, on a blockchain system. It sounds so fancy. So first thing first, we are getting the account service. So basically, you see the many code here, but this is just how the Java way to get the account service. If you return your CorDapp in colon, you can just call the account service, because the source code is written in colon. With Java, you need a little bit all these extra characters to call it. But this is basically the account service that we will need throughout the flow. And here it is. So what you see here is grabbing the account information for yourself. It's my account, right? I use the account service to call the method account info, and I put the parameter as who am I, which is a string. And we return the state, return the data, and then we get a new set of public key and private key pair for my accounts, ready for the transaction later in the flow. And step 2 is target account, right? I use account service again, account info, put in target accounts string, and then I will get the account info, and I will basically request the key for accounts for the target account. So we can actually look into this method a little bit further. So this is the source code of request key for accounts flow. So inside of the flow here, you see basically it's a if-else logic. So what we are looking here is if the host session is ourselves, we create a new key for the accounts. But if the host session is not ourselves, basically it's a counterparty, we send a message to the counterparty saying that, okay, it's your account, now give me a public key and private key pair. So there's actually a communications between your node and then the counterparty node when you call the request key for accounts, if the accounts that you want the key for is a counterparty account. So that's basically already the step 1 and step 2 for a typical Corda accounts flow. And the following, don't worry about it. It's just the flow logic for this specific start game flow. What we're looking at here is when we create the state for the transactions, we need to put the account's identity here rather than the node identity. Because think about it, whenever that we do a traditional Corda transaction, thinking about Corda state, you put your node's identity and you put your counterparty node's identity as, like, for example, the signature token CorDapp or the Bootcamp CorDapp, right? You put yourself as the issuer, you put your counterparty as the receiver of the token, right? But with the Corda accounts, you no longer should do that, because the transaction that you want to do are on the accounts level. It doesn't mean that you cannot do accounts to nodes transaction anymore. Remember in the previous slides that I showed that you can do 3 types of transaction: accounts to accounts cross node, accounts to accounts within the same node, or nodes to account, and vice versa. So, but I just want to like sort of like point it out here is, if the transaction that you're looking at is accounts to accounts, make sure your state is your state participant is your accounts, because that's gonna indicate where the state gonna store to, right? The next step is getting the notary and building the transaction builder. That's all the same. And here's the next somewhat different thing is when you sign the transactions, right? Originally we stop right here, get our identity dot get our owning key. But now, since we are doing transaction with accounts, right? So you can actually have your accounts key there. On a typical accounts to accounts transaction, you don't even need the node host owning key. You don't need a node key, you just need an account key. But it really depends on the design of your app. The next is collect signatures, and this one is a little bit different too. Is when we start the sessions, we set it to the target account's host node, because the session still goes to the node, because the node is the service engine that's gonna do all the work. So it doesn't make sense that you start a session to that specific account, because that account doesn't have the capability to process node level work. The account is just a label. And we are using the collect signatures method, and then we are taking the target account's owning key. So this is what we get in the second step. We remember, like, we request a key from the counterparty and say, oh, okay, I'm going to start do transactions with your accounts, right? Now, as a node, as his parent node, you need to give me a public key and private key pair, and not like not a private key, but you need to give me the public key for your accounts, right? And I receive it here, and then now in the collect signature flow, I'm requesting that you, as a node, and then your accounts, right, sign the transaction with that key that you just gave me. So that's basically the proper signature collection step for accounts related flows. Lastly, it's the same. You attach the signature with your transaction, and then you finalize it with a finality flow. I just want to show you that with the responder, everything is the same. You receive the finality. The counterparty, you don't need to do anything. So that's basically all you need to do with the flow involving Corda accounts. Any questions? Cool. I see there's a question in the YouTube chat saying, can we say that accounts are just like subnodes who participate in transaction only with account, not with a node? So as my colleague David said, is almost is not have the network. It doesn't have the network recognition as a node. So no matter how you try to push it to say, oh, it's a subnode, your other peers on the network will not see it as a node. So that's just like the technical explanation or technical breakdowns of like what the true aspect of Corda accounts. So Corda accounts can do transactions with other nodes. Corda accounts can sign transaction. Corda accounts can start do queries, can start flows. They can behave just like a Corda node, but they are not. You thinking about the question, you have to separate it from the business logic wise and the technical implementation wise. So today's workshop we're focusing a little bit more on the technical implementation wise, but on the business side, I mean, feel free to call it whatever you want, man. It's like it can just behave like a node. So that's what we want to distinguish here. I hope that answers your question. Cool. So let me actually go to the last step of the last steps of the flow logic is the query. So create accounts query criteria and query with accounts criteria. So let me see here, my game. Let me actually expand it a little bit. So as you can see here, so again, this is a tic-tac-toe game, right? When we do queries, I want to query the game that I'm currently played, or like or all the game that I played before, right? So the parameter is who I am, and that's basically that's account name. And first thing first is we are getting that account service, right? Again, this is a Java thing, right? If you are in Kotlin, you can just use the method, the interface directly from the SDK. With Java, you need to actually call it. But after we have the account service, we get my account, which by call the method account info, pass in the parameter who am I, and we have my account. And now we are creating a query criteria. So the query criteria goes as a vault query criteria, and then with external IDs. So this is where we see again, like the technical implementation of accounts is just a UUID, which is like also called external ID with of the Corda state, and some public key and private key pairs. When we do queries, we set aside all the public key and private key pair like stuff. We only care about the unique ID of the accounts. So that unique ID is a label that we put on the Corda state. And then when we do queries, it's very straightforward. You just like basically the node is like, tell me all the state you want with that specific IDs. I will get to you. So the behind the scene, the Corda node doesn't know what it's doing. So he's just thinking that he's querying some state with a specific external ID, which is the account UUID. And that's how we get all the data related or like stored it under our accounts, each account's database, or we can call it the sub vault. And as you can see here is, with the external ID, it's a array list of IDs. You can put one or you can put many, right? For example, Peter has account IDs like 1135, right? David has account ID like, let's say 8580, right? So you can have both Peter's ID there and then David's account ID there. So when you do the queries, you're gonna load up the states under both Peter's name and David's name. So that's just like standard Corda query stuff. And then lastly is again, you use a vault service, you use a query by, I'm looking for the game board state, right? And then I pass in my my account criteria, and then that's gonna return me the state. So that's the last step of data retrieval. You have to do this step. Otherwise, when you do a query, you're only looking for the board state. You're gonna load up everybody's account. So that's actually, yeah. That's a lot of responsibility are in the app developer's hand. Make sure your developer don't mess up this step. Cool. That's about it for the code here. Let me jump back to the slides. Cool. Last thing, as I promised, you know, as I promised, you know, I gonna show you some links. So with the accounts package SDK, you know, if you you can just go to GitHub, github.com/Corda, and then just type accounts. Then you're gonna see the accounts library there. But if you want to try some samples yourself, you can go, if you are a Java developer, you can go to samples-java/accounts. There's a folder with 3 accounts samples: supply chain, tic-tac Thor. Well, I mean, it's tic-tac toe game. It's called tic-tac Thor because one of our coworker, his name is Thor. He developed the game. But we, the DevRel team, we modify a little bit and then put it a little bit enhancement with the Corda accounts. And the last one is the World Cup ticket booking. So all 3 examples utilize Corda accounts to make it more scalable. Like you can have more participant in the applications rather than just a node. And any questions so far? Let me see. The question is, where can I find study material other than the slide? I mean, I think, you know, primarily you just go through the supply chain tic-tac Thor game, because the supply chain demonstrates all the possible transaction, the possible types of transaction. It has I can show you. So let me give me a second. Let me load it up. Okay, so now you are seeing the repository for supply chain. So the reason I suggest you start from here, because it's actually demonstrate all the different types of account transaction. On top of here is it's a accounts to accounts transaction. It's from seller sales and send the transaction to buyer procurement. And then the second step is buyer procurement to buyer finance. It's a accounts to accounts transaction within the same node, right? And then you continue here is from the seller inventory to the shipping company. The shipping company here is a node, and the seller inventory is account. So you see here is account to node transaction, and then here you see is a node to account transaction. So I suggest you start your studies from these samples, because from here you will see the flexibility, right? And then the second one is, you know, down to the list is tic-tac toe game. It's actually has a web server, so you can actually start it and play it yourself. So for this one is it's a second step, because you will get into a continuous transaction, because like the transaction is from A to B, right? From B to A, back to A again, and then A to B. It's going forward, back and forward, back and forward. So that's basically will give you a sense of like you are keep creating key pairs, and you are keep updating the database, and then all the accounts. Key management is like is expanding. So basically this is a more it's very practical, very very real. And the last one, the ticket booking one, actually I don't suggest you start from here, because this one is fairly complicated and it's involve tokens. So this is actually quite advanced. Cool. I hope that answers your questions, and yeah, that's basically it. And lastly, it's our thank you message. Thank you for joining our workshop today. We have another workshop next Thursday. It's on how to write test cases, like unit tests, integration tests, or like testings, and how to use progress trackers in your flow. It sounds pretty simple, but those simple stuff are sometimes the most most common things that people make mistakes on. So yeah, I hope to see you there. Again, it's Peter from the DevRel team. Thanks for coming to the workshop.